Hey everyone, my name is Firat Elbi. I'm a Principal Product Manager at Amazon AGI, and I'm really excited to discuss Amazon Foundation Models with you today. In this session, we'll begin with a recap of yesterday's announcement. Then we'll dive deeper into the capabilities of these understanding models. Joining me are my colleagues Imre and Fabian, who will showcase some of Amazon Nova's key features. We'll also hear from Peter Goldstein, Chief AI Product Strategist at Hearst, who will share their experience with Amazon Nova and the potential impact this will have across Hearst. Yesterday, we announced Amazon Nova, a new generation of state-of-the-art foundation models that deliver frontier intelligence at industry price performance. With Amazon Nova, we now have a range of models that can generate text from different inputs and models that can generate images and video from text. Okay, let's jump right into these understanding models. Amazon Nova includes 4 state-of-the-art foundation models in ascending order of intelligence, as shown on the screen. First, we have Amazon Micro, our text-only model that delivers the lowest latency responses at very low cost. The next 3 models are multimodal models, starting with Amazon Nova Lite, a very low-cost multimodal model that is lightning fast for processing image, text, and video inputs. Then we have Amazon Nova Pro, a highly capable multimodal model with the best combination of accuracy, speed, and cost for a wide range of tasks. And lastly, we have Amazon Nova Premier, our most capable multimodal model for complex reasoning and for use as the best teacher for distilling custom models. Let's take a closer look at what these models can do. At their core, these models deliver frontier intelligence, enabling them to perform a broad range of tasks at state-of-the-art accuracy. They have been designed for fast inference, with each model being one of the fastest in their respective intelligence tiers, making them really great for low latency applications. Fabian will talk more on this later on. Each model delivers exceptional price performance, offering state-of-the-art intelligence at the lowest cost. We have made these models easy to use and effective in agentic applications that require interacting with proprietary systems and APIs. Imre will talk more about this in the next session regarding agents. These models are not just on Bedrock, they are deeply integrated into it, with full support for agents for Bedrock, Bedrock knowledge bases, and Bedrock guardrails. Giving customers control was a key priority for us. That is why we enabled support for fine-tuning for Micro, Lite, and Pro that enables customers to improve accuracy using their own proprietary labeled data. We didn't stop there. Amazon Nova supports distillation using Bedrock's distillation service. Distillation is when you transfer knowledge from a highly capable model, which we call commonly as a teacher, to a smaller, more efficient one. Let's take a look at some of the key attributes and benchmarks. Nova Micro is a text-to-text model with 128K context length. It supports over 200 languages and provides support, as mentioned earlier, for fine-tuning and distillation using Nova Pro as the teacher to enhance accuracy for specific applications. Looking at the benchmark table, you can see clearly that Nova Micro is very capable on a broad range of benchmarks, leading in tasks such as language understanding, translation, reasoning, code completion, and mathematical problem solving. Using statistical significance testing and 95% confidence intervals, we found that our performance was equal to or better on 11 of 11 benchmarks compared to Llama, and 12 of 12 compared to Gemini. We considered models equal when their results overlapped within the 95% confidence interval. Micro isn't just intelligent, it's fast, with a speed of 210 output tokens per second, making it perfect for low latency applications. Nova Lite takes in text, image, documents, and videos, and outputs text, and offers a 300K context length. You're probably thinking what I mean when I say document as an input modality. So typically, models don't actually support documents natively. And even when they do, they typically just parse the text and ignore the images. So if you have a task that really requires understanding or parsing the image as well to complete, it won't work. With Nova multimodal models, you can pass documents as an input, and the models will use their visual capabilities to process the documents, understanding not only the text, but also the images, extracting much more value from these documents. Nova Light's accuracy on a broad range of tasks, coupled with its speed, makes it suitable for a range of interactive, high-volume applications where cost is a key consideration. It again offers multimodal fine-tuning, allowing you to not only enhance its text performance, but also its vision capabilities. And as I mentioned earlier, it supports distillation as a student using Nova Pro. And on the benchmarks again, Light is very competitive, excelling in visual tasks such as chart comprehension, document understanding, visual captioning, and visual question answering. Compared to OpenAI's GPT-4o Mini, Light is equal to or better at 17 of 19 benchmarks. It is equal to or better on 17 of 21 against Gemini, and equal to or better on 10 of 12 against the text-only Haiku 3.5. And Pro, like Light, can take text, image, documents, and video as input, and again, outputs text with a 300K context length. Its capabilities, coupled with its industry-leading speed and cost efficiency, make it a compelling model for almost any tasks, including video summarization, Q&A, and AI agents that can execute multi-step workflows. And Pro is one of the most intelligent models that allows you to customize through fine-tuning. Not just text, but like Nova Light, you can customize its visual capabilities using image and video content. And on the benchmarks again, Pro is very competitive. Equal to or better on 17 of 20 benchmarks against GPT-4o, and equal to or better on 16 of 21 versus Gemini. And compared to Sonnet, a model that's considered best in this class, Pro is equal to or better on about half the benchmarks. And on others, it's really, really close. The benchmark testing demonstrates that these models perform one of the best among their respective intelligence tiers and leading in many areas. And with the speed and cost effectiveness of these models, we think they're going to be very compelling. Let's take a look at our price performance. So as I mentioned before, Amazon offers industry-leading price performance. You can see here we're comparing to the same models that we just showed the benchmarks for. And based on the analysis performed by artificial analysis, these models are incredibly cost-effective, all ending up in the most attractive quadrant. And if we just focus on the models on Bedrock, Amazon Nova stands out as the most cost-effective family of models, with Micro, Light, and Pro at least 4 times more cost-effective than the best-performing models in their respective intelligent classes on Bedrock. Just before we get into the core capabilities, I wanted to briefly talk about Nova Premier. This will be our most capable model. We are very excited about some of its capabilities. It's expected to offer deeper levels of reasoning, critical for complex tasks that require multiple steps to complete. And we expect to make it available soon. Okay, let's jump right into some of the capabilities, starting off with native video understanding. Here we're asking Nova Pro to describe a video of a football game. You can see it provides rich, detailed output. Previously, customers needed to process these videos into key image frames and pass them as images to image understanding models, which requires a lot of extra steps, and it was very tedious to perform. Now with Nova Light and Pro, you can natively process video content on Bedrock for tasks such as video summarization. So here we have an example of Amazon Nova's understanding on handwritten documents. By simply providing an image and text prompt shown here, you can transform this data into a machine-readable format. Okay, let's see this in action. As you can see here, we have this example running in the background using Nova Lite. We did this in a simple chat interface just to demonstrate this capability. Nova Lite is able to accurately capture all the information on the image. It then outputs this information in JSON format for easy downstream processing. You can, of course, choose to have the model to output in any format you choose. With this capability, customers can effectively extract information from content such as handwritten invoices. I'm really excited to see what customers do with this. Okay, let's do something a bit more complicated. So here we have quite a busy diagram. And what we're going to do is we're essentially going to ask the model to summarize what's going on in this diagram. And then we're going to ask it to suggest improvements to this process. You can see the image and text tokens that we'll pass in a moment. Okay, so again, we have this example running, but this time with Nova Pro. Once the prompt is submitted, it will provide a detailed description, correctly identifying that the diagram illustrates a fluid handling system and explains what the system is actually comprised of. It then describes where such a system might be used, such as a chemical processing plant. When following up on how we can improve the process, Nova Pro provides a detailed suggestion, such as adding redundancy as an enhanced safety feature. Imagine how this can simplify documentation and knowledge transfer, enabling instant understanding of complex technical diagrams across teams and organizations. Now, I want to discuss something really exciting with you. We've discussed Nova's visual intelligence, its ability to understand what it sees. We've also seen its impressive performance in instruction following and function calling, which enable it to take real-world actions. This is clearly demonstrated by our performance on benchmarks such as IF-eval and Berkeley function calling leaderboard. Visual intelligence, instruction following, action taking. Can you see where I'm going with this? While these capabilities are powerful on their own, the magic really happens when you bring these two together. By combining visual understanding, instruction following, and agentic capabilities, Nova is setting new standards in computer agent benchmarks. We're seeing industry-leading performance across benchmarks such as Mind2Web, Visual Web Bench, and Ground UI. What this means in practical terms is that developers can use simple instructions with Nova models to create agents that naturally interact with websites, browsers, and screen-based applications. Let me show you this in action.
In this demo, we show how Amazon Nova models can power computer agents, which plan and execute multi-step actions using the browser and screen-based user interfaces as universal tools to automate tasks for end customers. Let's see an example of a sales representative interacting with a Nova-powered computer agent to use SAP S/4HANA. SAP is one of the most widely used SaaS ERP systems. Let's say the sales representative needs to change the shipping address for a particular order for a customer called Fit Cycles. They can ask the agent to do so in natural language, asking to update shipping order 5116 with the new information. From here on out, I will not touch the system. I'm not touching the mouse or keyboard. Combining Nova's visual instruction following and agentic capabilities delivers industry-leading performance on key computer agent benchmarks such as Mind2Web, Visual Web Bench, and Ground UI. This powers the agent's ability to navigate S/4HANA as you can see now. Through simple instructions provided to Nova models, developers can build these abilities to take actions on websites and browsers and screen-based tools. We can see here some of the agent's actions and intermediary thoughts, as it thinks step by step to take the next optimal step to achieve its goal of changing the delivery address. Right now, it is scrolling to find order number 5116 by navigating the UI. We see the agent autonomously actuating the browser on the customer's behalf. The agent understands the S/4HANA UI and interacts with the varied elements, such as entering in the customer information. It filled out a form. It can even click links and drop-downs. The agent had searched for the appropriate order, including the company name and order ID. And now we will update the form fields to set a new delivery address. The house number is just updated, as well as the district and now the postal code, the city, and the region. And there you have it. The agent has successfully updated the order information. And that is the power of Nova computer agents. Thank you.
So, as you can see, the possibilities with Amazon Nova are truly exciting. This is just scratching the surface of what's possible when you combine these powerful capabilities. Now I'd like to hand it over to my colleague Imre, who will take you deeper into Amazon Nova's capabilities as an agent and show you even more of what it can do.
Thank you, Firat. Hi, everyone. My name is Imre Kish, Science Director with Amazon AGI, working on Nova. In the SAP demo, you saw an example of the Nova computer agent autonomously driving the browser on behalf of the user directly on the S/4HANA website with a single, simple natural language statement. I'm going to show you another demo that I'm very excited about. Again, it leverages Amazon Nova's multimodal agentic capabilities. But first, I wanted to dive a little bit deeper into a few benchmarks that quantify our performance in some of the dimensions we discussed. One of Nova's core capabilities is its industry-leading price performance on agentic workflows. These workflows enable developers to build applications that use retrieval augmented generation, RAG, API execution, or UI actuation, such as predicting API actions to automate client applications. A central capability of agents is the model's ability to accurately call APIs, functions, or tools based on an input. We therefore benchmarked Nova on the Berkeley function calling leaderboard that evaluates a model's ability to accurately call and utilize real-world functions based on natural language requests from a user. As you can see, Amazon Nova models particularly excel in AST, execution, and multi-turn metrics. These capture the model's ability to understand often ambiguous user requests, accurately translate these into API calls, ensure that accurate responses are obtained from real-world APIs, and achieve this as a conversation progresses, changes trajectory over multiple turns. Nova's performance holds both on the BFCL team's original curated test set called non-live, as well as the user-collected live test set that includes a much larger set of tools and ambiguous requests. Overall, based on the performance across 18 different function calling categories in BFCL, Amazon Nova models deliver industry-leading accuracy in their respective intelligence tiers for a fraction of the cost and latency. Accuracy, cost, latency, all three of which are critical to scaling successful agentic applications. Nova Pro and Lite provide native support for multimodal inputs, including agentic workflows. They demonstrate strong visual reasoning and agentic capabilities as measured by 3 benchmarks that require agents to navigate websites and solve real-world tasks. Visual Web Bench evaluates web page understanding capabilities of models to determine actions on the UI elements based on user query. Mind2Web evaluates the end-to-end execution capability of web agents from user intent to the output. Ground UI evaluates the grounding ability, which is important for agentic models to identify the location of UI elements on the screen. As you can see, both Nova Pro and Lite excel at these tasks. Based on this data, Amazon Nova Pro in particular outperforms other models, making it the best model today to power intelligent UI automation workflows. We saw earlier how Nova enables computer agents. We can combine that functionality with its state-of-the-art agentic capabilities of instruction following, multi-step action planning and execution, API calling, and multimodal reasoning to automate real-world workflows from end to end. Let's watch a demo here of an AI on-call agent which automates the process of root causing service issues by gathering all the relevant data, including metrics, logs, deployment statuses, and so on, through actuating APIs and the browser. It ultimately determines the root cause by analyzing data from all these sources.
In this demo, we show how Nova can power computer agents, which plan and execute multi-step actions using the browser as a universal tool to automate tasks for end customers. Let's see an example of an on-call engineer interacting with my on-call agent, Mocha, a Nova-powered computer agent, which autonomously root causes service issues by actuating APIs or the browser to determine the root cause. First, Mocha generates a plan based on information cut in the ticket overview. The computer agent uses a React loop, gathering information from tools available to Mocha and determining whether or not we can root cause the issue at each step. Mocha has a library of tools available to it. It either uses APIs to access information, such as logs, or can use the browser to access other information, such as service metrics. This is possible because Nova is able to understand UIs and actuate the browser, enabling computer agents that orchestrate across both APIs and UIs. At this point, Mocha determines it needs to look into the service metrics, which requires navigating the CloudWatch UI. The computer agent autonomously drives the web browser to do so. It finds the error graph associated with the information it gathered from the ticket. It enlarges the graph and passes that image to Nova to reason through it. Through its capability for multimodal understanding and reasoning, Nova is able to correctly identify the time of the spike and value to get closer to further root causing the issue. The final comment on the ticket is the root cause and Nova thinking. Mocha has correctly identified the root cause is due to a recent code commit of unused client IDs from the system.
How cool was that? I can't wait to see what customers will build with these models. All right, so let's take a quick look under the hood. What did it take to build Mocha? First, Mocha's overall architecture is actually quite simple. The user interacts with the Mocha computer agent, which carries out the overall orchestration of tasks written as a React loop. Mocha uses Nova Pro for multimodal reasoning, instruction following, and tool calling across API and UI actuation tools. It uses API tools such as service description and logs to collect the necessary data about the service. It also uses UI actuation tools through the web browser to execute actions on behalf of the user, such as finding and analyzing service charts in CloudWatch, as we've seen in the demo. Nova Pro generates a plan to determine the agent's next step based on all information gathered so far. And it achieves its goal when it's able to successfully identify the root cause, at which point it posts final comment on the ticket. Here you can see the agentic workflow Mocha uses. You might wonder what were the basic steps that the developer had to go through to build this. First, define the system prompt. A basic natural language description based on the goal of the agent. Then define the tool library available to the agent, structured form with simple natural language descriptions both for API and UI-based tools, such as UI-based tools that have access to data sources such as the CloudWatch dashboard. Then implement the tools using the appropriate client libraries, and implement finally the React scaffold that allows the model to cycle through the planning or tool selection, tool calling, and root cause determination steps. In the last step, the model judges whether it had reached the root cause or needs to continue to gather more information. Overall, Mocha is just about 400 lines of code and natural language statements with 4 API and UI tools. This should give you a sense of what's possible with agents on Nova. But the code and the tools will, of course, vary depending on the specific system you want to build. In summary, when you combine the state-of-the-art function calling as we've seen in BFCL, and multimodal reasoning, as seen in mind-to-web capabilities of Nova Pro, you can unlock the ability to build agentic applications like Mocha. Now, I'm going to hand it over to Fabian, who is going to share more of Amazon Nova's core capabilities to make experiences like this possible. Thank you.
Okay, thanks, Imre. Hi, everybody. I'm Fabian, Science Manager working on the Amazon Nova models, and I'm very excited to speak today on what we have built. We already mentioned that our Nova models offer the best out-of-the-box price performance, but there's more. We also offer very easy customization via fine-tuning. So using your custom data, specifically prompts and responses, customers can improve the zero-shot accuracy of our Nova models for their custom use case. As a result, your customized Amazon Nova models will provide an even better price performance offering, and we reduce the effort for you to spend no time on prompt engineering or very long and expensive prompts. And customers can fine-tune all our Amazon Nova models, so that includes Micro, Lite, and our most powerful Pro model. And also for the multimodal capabilities, we are offering our customers that you can fine-tune the model to improve context-specific responses for images or video inputs. In addition to fine-tuning, we also offer that you can further improve our Amazon Nova models via distillation. And here we are using Amazon Nova Pro, our most performing model, as a teacher to improve the accuracy of your Amazon Nova Micro or Lite model. Assuming you only have a small amount of labeled data or just a collection of prompts without any response, Nova Pro as teacher can help you to generate additional synthetic data, which you can use for fine-tuning and training your perfect model. With this, we provide you actually the speed of our very fast Nova Micro and Lite model, combined with the intelligence and the generalization capabilities of Amazon Nova Pro. And to provide a little bit more practical example, we have worked with customers who fine-tuned early versions of Nova Micro and Lite. And what I show here on this little slide is that we take our Nova Micro model and we have optimized it, we are fine-tuning to solve a specific task of function calling. So you have 17 APIs, and the model needs to orchestrate across these APIs. And fine-tuning the Nova Micro model, you can see that the accuracy is already significantly increasing and already reaching or outperforming the Nova Lite model out of the box. And compared to GPT-4 Mini, which is the baseline for this task, out of the box as well, we see that our smallest model can already exceed this performance. And if we apply the same fine-tuning on the Nova Lite model, which has more capabilities, a bit more expensive, and this model will clearly outperform the 2 times more expensive GPT-4 Mini, and doing that with 30% faster inference. And this practical example shows that customizing models, especially our Nova models, is offering an even better and industry-leading price performance for our offerings, and provides you as customer with the full flexibility to build the right solutions for your customers. So please all get started today, supercharge your Gen AI applications with your custom Amazon Nova models. And speaking of industry-leading performance, we're also proud to provide a little bit more detail on how fast Amazon Nova models solve understanding tasks. So we know that low latency cannot be compromised for many real-world use cases, and we therefore designed our Nova models with speed in mind. So a common way of measuring how fast models are is to look at the output tokens per second. So taking a fixed input and a number of tasks, we just measure how many tokens per second is each model generating. And in this figure, it's again taken from artificial analysis.ai. We are comparing a set of models in the same category of intelligence. And you can see that Amazon Micro, Lite, and Pro all show low latency, which means high number of output tokens, a high bar in this plot, and that they are the leading models in their respective intelligence classes on Bedrock. And I would also like to call out that all the Bedrock models will also benefit from the new and yesterday announced latency-optimized Bedrock inference, which will help all our models on Bedrock to get a boost in accuracy, if you like. And as speed is not the only aspect of a model, in this slide we are putting a little bit into perspective how the model accuracy relates to the speed. So on the one axis, we have the output tokens, the ones we just have seen as a bar plot, and we have the quality measured by artificial analysis.ai via a group of standard benchmarks where they actually compare the models. And you see, in this case, the nice place you want to be is the top right corner, the green area. And both our light and micro model are very well placed there, comparable to the best models on the market, being the fastest or being more accurate, depending on how you put the pressure. And the same we can do for our Pro model. It's also ending up in the green top corner and offering fast speed. And the interesting observation here is as well, the size of the dot in these plots is indicating how expensive the models are. So our small Nova dot is actually a good sign compared to the larger dots you see on this plot. And next, I would like to talk a little bit about accuracy of Nova models about different context lengths. We already shared a lot of performance numbers on downstream tasks, and we also spoke about agents, RAG, and these details. And we know it's a customer demand that models are very strong handling input context. And we therefore designed our Nova models from ground up to perform very well on long documents and to offer best performance for complex document understanding. And this also includes multimodal documents, chart understanding, and all these topics. As a measurement on this slide, we are using the needle in a haystack task. So it's a very popular or common task to measure the ability on how to locate specific content that is hidden in a longer document. So depending on how long you pick the document, there's somewhere a sentence in this document that's relevant, and the prompt has to find that answer to that sentence. And as you can see in this little table in the middle, our models, Micro, Light, and Pro, score very strong numbers on 128K context lengths, be it Micro at 97%, Light at 98%, and Pro at 99%, meaning that they almost every time retrieve the right information from the documents. And in this little plot on the left side, it's a kind of heat map where we see different context, 32K, 64K, 128K, and depending on where you hide the needle in the text documents. And given how much green you see on this plot, it indicates that the Nova model Micro, which is shown on this slide, is very strong in handling any types of hidden information in this, which makes it very strong for RAG and other retrieval tasks. And 128K is nice, but it's actually not the limit of our models because it's only the limit of the Nova Micro model. The Light and Pro model both support 300K context, which is the currently longest offering we have on Bedrock. And they do also with great precision. As you can see in all the green dots, especially the Pro model is very strong up to 300K in delivering this context. And before I'm handing over to Peter, who is our customer talking, I'm thrilled to also pre-announce that even the 300K I'm showing here is not the limit for Amazon Nova understanding models in the future. So our models are already capable to handle much longer context. So here I also plot or show how the heat map looks like for up to 1 million token input lengths. And the accuracy is very nicely distributed again. And today I'm going to pre-announce that we are soon offering up to 5 million token long windows, and that will be available soon next year. And now I'm handing over to Peter, Chief Product and AI Strategist at Hearst Corporation.
Hi, everyone. I'm Peter Goldstein, Chief Product and AI Strategist for Hearst, and I'm very excited to be here to tell you a bit about Hearst, our generative AI journey, and why we're so excited about Amazon Nova. So first, let me tell you a bit about Hearst. Hearst is a company that does billions of dollars of revenue. It's a multinational conglomerate with over 22,000 employees, and it's very likely you're not terribly familiar with the brand Hearst. But it's very likely that you're very familiar with some of our brands of various subsidiaries. So Hearst is a company that covers a lot of different verticals. We have Hearst magazines, so brands like Cosmopolitan, Good Housekeeping, Car and Driver, etc. These are likely brands that you'd be more familiar with than our corporate brand. Similarly, we have newspapers, San Francisco Chronicle, Houston Chronicle, and others, as well as television stations in over 35 media markets. But Hearst has a strong media arm where it has coverage in magazines, newspapers, and television, as well as joint ventures with joint venture ownership of A&E and ESPN. We're also more than that. we have a substantial B2B arm, which includes Hearst Health, which has brands like FDB and MCG, as well as Qgenda and others. We have an extensive transportation portfolio where we cover both automotive with businesses like Motor and Black Book, and aviation with Camp. And finally, we have the Fitch Group, which is our financial arm, which includes the most well-known company out of that is Fitch Ratings. So Hearst is in the position of covering a large number of verticals, and that gives us the ability to see how this kind of generative AI technology can impact businesses pretty much across the board. So generative AI has been a priority at Hearst for the last 2 years. You might ask why. The reality is that while we're in a bunch of different verticals, our businesses, many of them are essentially information processing businesses. We ingest information, we curate it, we transform it, we then offer it as data and services to our customers. And that's obviously a strong suit for generative AI technologies. And so we've really invested very heavily. Our executive team, led by our CEO, really understood this was a priority for us and invested heavily in generative AI over the last couple of years. Focusing on training. We've done training across our entire employee base, led by instructors, to really make sure they're comfortable with generative AI and understand its capabilities and really get some hands-on experience. We've built our own internal portal for doing generative AI chats, as well as building generative AI applications, where we allow our employees to have access to all of the state-of-the-art models, including the Meta, Anthropic, and now the Amazon Nova models through Bedrock API. We work with our organizations to identify places where they can really see enhanced productivity. We have a team that meets with all of those different businesses and looks for high ROI opportunities where generative AI can really transform the business's workflows. And finally, we're really focused on discovering how generative AI can enhance our customers' experiences directly, where we might offer them Gen AI capabilities through our interfaces, but also where we may be able to offer new types of experiences to them by having the back end powered by generative AI capabilities to make that possible. We're very excited about Amazon Nova because we see some of the key use cases that will be really meaningful for our business. Here are just a couple of examples. The Fitch Group, which I mentioned is our financial arm, really needs to process large volumes of information, often extracting a relatively small number of data points from a document that might be dozens or hundreds of pages of content. So having a powerful document processing model that can not only handle text, but also graphs and charts, understand that information, identify it, when it may not be in the same place in different documents or documents that cover different cases, but really pull that together and bring that so that we can use that in the information we're providing to our customers. We also have lots and lots of workflow processing needs. I'll just talk about one, which is importing healthcare authorizations. So we have situations where we want to do healthcare workflow processing. We have a couple of companies do that, and they get authorizations from insurance companies that come in. They need to process those. They need to match them to the particular cases, et cetera. Being able to do that in an automated way, in a way that leverages the ability of image processing, because many of these things come in on, as much as we might hope wasn't the case, faxes and other technologies that really don't allow the kind of text processing that you might get if you got clean PDFs and the ideal scenario. We see similar issues in the transportation world, where in general aviation, your maintenance record might come in as a clean PDF from, say, an airstrip in Dallas, Texas, but maybe not from an airstrip in Dubai or some other part of the world. What's more, we often need to extract information that's not necessarily on the form itself, but in handwritten notes on top of it. The Amazon Nova model, family of models, promises to give us the ability to do that workflow processing at a level that will allow us to really optimize these processes, make them faster, more efficient, and just basically deliver a better value to our customers. On the media side, much of what we have to do is consume information, understand its impact of what we want to report. So in some cases, that's a question of keeping up with trends, things that are happening on, say, a TikTok or an X, where we might want to consume video content to identify this is a new emerging product and Good Housekeeping wants to make sure that they do a review on it as fast as possible. Or this is a new fashion trend and Elle wants to make sure that they can report on it, give that to their customers, tell them what it's like. It might be that we have a local town government meeting that might be 3 hours long, but there are really only 2 or 3 issues that are of newsworthy importance that we want to extract. And realistically, we may not have the ability to cover all of those with in-person reporters. Being able to extract that information, to understand it, and then make use of it as an input to our content generation process is really powerful for us. So I want to tell you a bit about about an experiment we ran with the Amazon Nova model. We were lucky enough to get early access to it. And what we did was we took a look at video ads. So we're a media company. We have ads that in many cases are submitted by our companies. What we really wanted to do was say, can the model give us a sense of whether an ad is likely to be successful on our platform, right? And to do that, the model needs to understand the ad. So it needs to be able to not see the details that are in the ad, understand the images, but also, and more importantly, understand the narrative of the ad. What is the message that the ad is trying to put forth? How is it connected? So for example, we had a car company ad that showed the development of automotive technology through time and had an individual sort of in different factories, different levels. The Nova model was able to understand that narrative and really get a good sense of what the ad was for. We also need to be able to tell the ad, who's the target? Tell the model, who's the target for this ad? Who are we trying to reach? And how will other people, we want to give it a question of how would other people we're not trying to reach react to it? So we were able to draw up personas and then provide those personas as steering prompts to get different perspectives on the same video content. How would it be successful? And then critically, it's not enough for it to sort of extract very factual information, right? The fact that it displays a car or that it has an engineer going through time. What it needs to be able to do is tell you something about how people are likely to react to this emotionally, to give you some aesthetics, what the tone is it over the top? Is it right on point for the persona that we've presented? And Amazon Nova was very successful at providing feedback beyond kind of the simple facts that really allowed us to say, okay, this is something that we could provide to our customers and say, here's the ad you gave us, here's what our model is saying it's likely to be received. Maybe there's something we could do to change it, or maybe it's right on point for the persona that you're aiming for, and give them that information to help us figure out our placement. So we were very excited about these results. We feel they're an important step forward for that capability. In general, we see tremendous impact of this kind of capability across the Hearst businesses. Visual understanding at scale is one of the things that's been missing from the bulk of models that have been available. And it's many of our processes, many of our back-end processes really require human beings to evaluate documents, review things at the speed that human beings go. And so having a model that can do pre-extraction, that can pull information, that can understand the context and present that to our employees who can then review the material, make sure it makes sense, while still keeping a human in the loop is super important. What's more, again, our perspective across so many verticals allows us to see the wide number of applications. We see a multitude of opportunities across media, finance, automotive, and health. Honestly, we have only begun to scratch the surface on how this could optimize workflows, enable us to move faster and more nimbly for our customers, expand the offerings that we give our customers by being able to consume more data and therefore produce more content based on that. And as a result, we see tens of millions of dollars in estimated savings from this kind of capability coming to our organization. So we are very excited about the Amazon Nova model. We're very excited about these capabilities and what they can do for our business. Farhat?
Thank you.
Thank you.
Thanks, Peter. It was really great hearing about some of the different applications across Hearst's portfolio of businesses and Peter's experience with Amazon Nova models. Just to recap, in this session we went through the different understanding models we're GAing. We also just briefly touched on the content creation models. We also introduced a few exciting products and features coming soon. So obviously we covered Nova Premier, and Fabian introduced the 5 million in context length. I also mentioned that the latency optimized inference capabilities will also be coming soon. But there's more. And as Andy mentioned, we're going to have a new speech-to-speech model that can accept speech and text as input and generate speech and text as output. We are also working on a more capable any-to-any model that takes in text, images, audio, video, and speech as input and generates outputs in any one of those modalities, all in a single model. This is so much more convenient for customers that need to support multiple modalities in their applications versus having to pick and choose from different models or string models together. It's truly exciting what you can do with this any-to-any model. And you can expect these models to be coming early next year. So if you're ready to begin your journey with Amazon Nova, go check out our model on Bedrock and run evaluations against your current implementations, or simply take it for a test drive in our playground on Bedrock. I also encourage you to scan this QR code and bookmark the page to get quick access to resources like prompt guides, quick start recipes, and much more. Also, please check out our other sessions like workshops, AIM392, where we'll go through an end-to-end, hands-on experience with the Amazon Nova understanding models. If you'd like to hear more or have any questions, you can find us in the AWS Village kiosk, Zone 2, and we have a lot of our folks there ready to answer any of your questions. Thank you so much.